Hello friends, I am Balaji Rao from the Masters PU College. In last class, we completed up to exercise number 4.5 in determinants. This is the last exercise in determinants. This is exercise number 4.6. First, we will learn theory part related to exercise number 4.6 and then we will start exercise problems. From this exercise, one 5-mark question, 100% guarantee in final examination. Right. You see, what is the theory part related to this exercise? They'll ask questions like this. Solve linear equations by matrix method. The 5-mark question will be like this. Solve the given linear equations by matrix method. What are linear equations? You see here, a1x plus b1y plus c1z. This is one linear equation. a1x plus b1y plus c1z equal to d1. Like 2x plus 3y plus 4z equal to 6. An example I am saying. This is one linear equation. This is another linear equation. This is another linear equation. In our exercise, 2 by 2 matrices as well as 3 by 3 matrices are there. So, they may give 2 linear equations with 2 variables. They may give 3 linear equations with 3 variables. What I am trying to say, they'll give equations like this, 3 equations. We need to solve these linear equations by matrix method. Solving equations means what? Solving equations means we need to find these unknown values x, y, z. We need to find the unknown values x, y, z. Okay. Solving equations means by solving these 3 equations, we need to find what is x value, what is y value, what is z value. This solving we already know from 7th standard onwards. We are solving the equations by subtraction method, by substitution method, like that. But here by using matrix method. By using matrix method, how we solve linear equations. To solve linear equations by matrix method, first given equations you write in the matrix form. For example, whatever the equations they given here, those equations can be written like this. You see here, this is known as coefficient matrix. You see here, in this equation, coefficients a1, b1, c1, that I written. In this equation, coefficients a2, b2, c2. In this equation, coefficients a3, b3, c3. From the given equations, first you should write this form. This is matrix form. First you write like this, coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3. Next, unknown values x, y, z. In this equations, unknown values are x, y, z. Unknown values. Equal to, this is a constant matrix. Here, what are there here elements? D1, D2, D3. Here, what you need to understand, when we multiply these two matrices, I am going to get this set of equations only. You know how to multiply the matrices. Multiply. How to multiply the matrices? First row, first column. This is 3 by 3 matrix. This is 3 by 1 matrix. After multiplying, you will get a matrix of order 3 by 1. How to multiply the matrices here? First row, first column. Multiply a1x plus b1y plus c1z. You look here, we got the same thing here. Equal to, when I equate both the matrices, you will get d1. Understand? Now multiply further, second row, first column. Multiply a2x plus b2y plus c2z. When I equate, what I will get? Equal to d2. What I am trying to say, when you multiply these two matrices and equate left hand side, right hand side, then you are going to get these equations only. What I did till now, they given 3 linear equations. We learn how to write into matrix form, right? I'll name this matrix as A. From now onwards, in this exercise, A means coefficient matrix, X means unknown matrix, D means this constant matrix, right? Whatever after equal, whatever the numbers will be there, that matrix. Okay. What I did, the given linear equations I written in the form of Ax equal to B. See here, Ax equal to B. I just written A into X equal to B. Solving equations means we need to find the unknown values in the given equations. That means we need to find X. I written given linear equations in the form Ax equal to B. Now I want to calculate X because X is the unknown matrix. What is X? You see here, X is XYZ. I want to calculate the matrix X. Okay, what I do for this equation Ax equal to B, I am going with A inverse. Left cancellation law is there, and I am multiplying with A inverse on the left hand side. Multiply with A inverse AX equal to A inverse into B. We know from earlier classes, A inverse into A is same as I. A inverse into A is same as I. So this is Ix equal to, this is as it is, A inverse into B. I just multiplied with A inverse on the left hand side because in matrix multiplication, left cancellation law holds good, right? Okay, now I got Ix equal to A inverse into B. Ix, we know this property, Ia equal to Ai equal to A, right? Ix equal to Xi equal to X. So we know that Ix is same as X. X equal to A inverse into B. So what is X here? What is X here? X is this XYZ. Okay. A inverse. We know what is A. A is the coefficient matrix. When we know the matrix A, we know how to find A inverse. That in earlier classes we learned how to find A inverse. And the matrix B we will get from these equations only. These constants are there on the right hand side after equal. That is the matrix B. I hope you are understanding. See, for this exercise, this is the hero of this story. For this complete exercise, this is the formula. We are going to solve the linear equations. Solving linear equations means we are going to find x, y, z values. That means we are finding capital X. To calculate capital X, what is the formula? A inverse into B. What is A? Coefficient matrix. When we know coefficient matrix A, we can find its inverse by using the formula. A inverse formula is what? 1 by det A into adjoint A. So this is the main hero of this exercise. So what formula you should remember? Solve linear equations by matrix method means you need to remember this formula, x equal to A inverse into B. Okay. So what you learned till now in this class? How to solve linear equations by matrix method. First they will give 3 equations. Those 3 equations we will write in the form of Ax equal to B. After writing in the form of Ax equal to B, to calculate this x, the formula is A inverse into B. I'll calculate A inverse and I'll multiply with B and then I'll get the matrix X. How? All those things we will learn in exercise problems. Okay. And another 2 concepts are there. One is consistency, inconsistency. When we say given system of equations is consistent, when we say given system of equations is inconsistent, 2 things are there. A system of equations is said to be consistent if its solution exists. That means when we are able to find capital X here, when we are able to find capital X, then we say the system is consistent. You will come to know clearly when we do one first problem or when we do few problems, then you will come to know what is this consistency, inconsistency. What is the definition of consistency? A system of equations is said to be consistent if its solution exists. That means in the process of calculating this x, if I am getting the answer, then the solution exists. Then we say that given system is consistent. Simple words. A system of equations is said to be consistent if solution exists. If solution doesn't exist, then it is inconsistent. A system of equations is said to be inconsistent if its solution does not exist. Right? So total 3 things are there in this theory part. If you know these 3 things, we can start exercise problems. What are those 3 things? We know to solve linear equations by matrix method, formula is x equal to A inverse into B. Based on this formula only, they are asking 5 mark question. And another 2 things are there in this exercise. One is consistent, another one is inconsistent. When we say the system is consistent, when given system, for the given system, if the solution exists, then we say system is consistent. For the given system, if solution does not exist, then we say the system is inconsistent. This class is all about consistency and inconsistency only. In next class, we are going to do the 5 mark questions. But many students will feel little difficulty to understand this consistency and inconsistency. To avoid the confusion, I am going to tell you 3 cases here. You listen those 3 cases carefully so that you will never confuse in this consistency and inconsistency part. Okay. You look here, how to check consistency and inconsistency of system of equations. they'll give linear equations. They'll give linear equations, 3 linear equations, 2 linear equations, like that they'll give some linear equations. We need to check that given system of linear equations is consistent or inconsistent. We need to check. Okay. First thing, whatever the equations they'll give, you write in this form. First coefficient matrix, next unknown matrix, next that constants after equal right hand side will be there. Na? First you write given system of linear equations in this form, Ax equal to b. Here what is A? A is coefficient matrix. Just now we learned what is coefficient matrix. However, we are going to do few problems in this exercise. There you will understand more clearly. First thing, given system of linear equations, you write in the form of Ax equal to b. Okay. Now, first thing, after writing this system of linear equations into matrix form, you identify coefficient matrix A. Okay. Det A you calculate. To check consistency or inconsistency, you just calculate det A. If det A is non-zero number, if you got det A answer is not 0, then the system is consistent. Problem is over. There is no question of second case, third case here. First write given system of equations into matrix form. You identify what is matrix A. You just calculate det A. If det A is not equal to 0, feel happy because the problem is over. If det A is not equal to 0, then we say system is consistent. Why system is consistent? All those things in the coming exercise problems I'll explain in detail. I don't want to confuse you now, right? So you try to understand the theory. What is the theory? If det A is not equal to 0, feel happy. Say that system is consistent. And moreover, it consists unique solutions. I'll explain about unique solutions while doing exercise problems, right? Okay. In case det A is 0, then det A is 0, then you need to calculate another part. If det A is not equal to 0, it's over. It's consistent. In case you calculated det A, you got answer 0. Then you need to calculate adjoint A into B. Adjoint A, you learn in the earlier classes, last exercise. What is adjoint A? Transpose of cofactor matrix is called adjoint A. You need to calculate adjoint A into B. You need to calculate adjoint A into B. When we calculate adjoint A into B, adjoint A is a matrix, B is a matrix. When we multiply both the matrices, if you are getting a matrix which is non-zero matrix, see here this is matrix, this is matrix, this is matrix. When we multiply two matrices, again you will get a matrix. That matrix is non-zero matrix. Then we say the system is inconsistent. I'll explain these things in detail. You just try to understand what are the 3 points we have. What are the 3 points we have? First thing, calculate det A. If det A is not equal to 0, feel happy, say system is consistent, the problem is over. In case det A equal to 0, two things will arise. One, first thing, you need to calculate adjoint A into B. Adjoint A into B is non-zero matrix, then we say the system is inconsistent. In case adjoint A into B is 0, you see this third case, adjoint A into B is 0, then we say the system is consistent. Why? All those things I'll explain while doing the problems, right? I hope you understand what I am saying. These 3 points are very, very important. See, here actually it seems to be like 3 cases, but 2 things. One is det A you calculate. If it is non-zero, the problem is over. If det A is 0, then 2 things you need to calculate. Then you need to calculate adjoint A into B. When we calculate adjoint A into B, 2 things may happen. Adjoint A into B is non-zero, adjoint A into B is 0. If adjoint A into B is a non-zero matrix, then we say the system is inconsistent. If adjoint A into B is 0, then the system is consistent. Why? All those things I'll explain while doing the problems, right? So to check whether the given system is consistent or inconsistent, you need to calculate det A. If det A is non-zero number, the system is consistent, the problem is over. If det A you got 0, then you need to calculate adjoint A into B. If adjoint A into B is non-zero number, the system is inconsistent. If adjoint A into B is 0, then the system is consistent. You need to know these 3 points. Now we are going to start exercise problems. Exercise number 4.6. Total 6 problems are there related to consistency. So in this class, first I am doing consistency, inconsistency related problems. Examine the consistency of system of equations. From first 6 questions, they are asking, this is the statement. Examine the consistency. First 6 questions, right? They given equations like this. These are the linear equations. We need to decide they are consistent or inconsistent. To decide given equations consistent or inconsistent, you just write the given equations into matrix form. Ax equal to b. Writing this is very easy. See, coefficient matrix. X coefficient is what? X coefficient is 1. Nothing is there means 1 will be there. 1. Here y coefficient is 2. Okay. Here x coefficient is 2. Y coefficient is 3. Now unknown values are what here? Unknown things are x, y. Right? Equal to. This is b. 2, 3. Ax equal to b. You take this matrix as A, this is x unknown matrix, this is b. Okay. Now after writing given linear equations into matrix form, you just calculate det A. Just calculate det A. Determinant of this 2 by 2 matrix, 1 into 3 is 3 minus 2 into 2 is 4. 3 minus 4 is minus 1. Minus 1 is 0 or non-zero? It is non-zero number. Det A is non-zero. This tells that given system of equations is consistent. If det A is not 0, what is the first case? If det A is not 0, then we say the system is consistent and it has unique solutions. In this, I am not finding the solutions. While finding the solutions, I will explain the things, right? Here, 3 points are there. First, they are asking consistency of the equations. For that, what to do? You need to calculate det A. If det A is not equal to 0, feel happy, the problem is over. We say the system is consistent because it consists unique solutions, right? If det A is 0, then you should go for second point. What is that? Adjoint A into B. Okay, right. Now we'll move to second question. For the second question also, statement is same. They are asking, examine the consistency of the given linear equations. What I'll do first, I'll write this in matrix form. A means coefficient matrix. Here x coefficient 2, y coefficient minus 1. You have to write these things very carefully. Y coefficient minus 1. Here x coefficient 1, y coefficient 1. Unknown values x, y. What is this constant matrix? 5, 4. Ax equal to b. After writing Ax equal to b, you just calculate det A. Det A, 2 into 1, 2 minus 1 into minus 1 is minus 1. Minus of minus plus, this is 3. 3 is non-zero number. That means det A not equal to 0. Feel happy. Det A not equal to 0 means feel happy. Why? Because when det A is not equal to 0, directly we write the system is consistent. Okay. In case det A is 0, then what to do? We will learn in the coming problems. You see what they are asking in this question, examine the consistency of the equations. They given 2 linear equations. We need to examine the consistency. First, I will write given equations into matrix form. See, x coefficient 1, y coefficient 3, x coefficient 2, y coefficient 6, unknown values x, y and 5, 8. Ax equal to b. Matrix form. Now you just calculate det A. Calculate det A. 1 into 6, 6 minus 2 into 3, 6. 6 minus 6 is 0. See here, det A is 0. Somewhat we need to do this problem further. If det A not equal to 0, here only we will write directly the system is consistent. But here det A is equal to 0, we cannot write system is consistent, inconsistent or consistent here. At this point we cannot decide. If det A equal to 0, the system is inconsistent, we cannot decide. We need to go with adjoint A into B, right? So first I will calculate adjoint A. As it is the 2 by 2 matrix. As it is the 2 by 2 matrix, we can write its adjoint A very easily. How you will write adjoint A of 2 by 2 matrix? You just interchange these two elements, 6, 1, and change the sign for these two. Here plus 3 is there, now you write minus 3. Here plus 2 is there, now here minus 2. From the third exercise onwards, we are doing this adjoint A. By this time, you must be good in these things, I think. So how to calculate adjoint A of 2 by 2 matrix? You just interchange these two elements, change the sign for these things. Adjoint A. This is the matrix B. What I will do now, I will multiply adjoint A into B. Now you need to observe one thing here. Adjoint A is a matrix and B is a matrix. You know matrix multiplication. This is 2 by 2 matrix. This is 2 by 1 matrix. When we multiply these two, you will get 2 by 1 matrix, right? You know how to multiply the matrices. In case if you do not know multiplication of matrices, please go through matrices chapter and learn matrix multiplication first, right? Matrix multiplication, this first row, first column, 6 into 5, 30, plus minus 3 into 8, minus 24. Second row, first column, minus 2 into 5, minus 10, plus 1 into 8, 8. If you simplify this, I am getting like this, 6 minus 2. Is this matrix is 0 matrix? What is 0 matrix? If all the elements of a matrix are 0, then we say it is a 0 matrix. Here, not even one element is 0. What is 0 matrix? All the elements of the matrix are 0, then we say it is 0 matrix. We can easily say it is a non-zero matrix. So I calculated adjoint A into B. Adjoint A into B is non-zero. So when adjoint A into B is non-zero, so what happened here? We calculated det A, we got answer 0. When we got answer 0, then we will go with adjoint A into B. Adjoint A into B is non-zero. Adjoint A into B is non-zero means the system is inconsistent. Second case. What is second case? We will discuss it in today's class only. Det A equal to 0 and adjoint A into B is not equal to 0. Then we say the system is inconsistent. In case adjoint A into B is 0, then we say the system is consistent. That is the third case. Okay. So you need to remember those three cases. They'll give linear equations. They'll ask to check the system is consistent or inconsistent. You will identify the coefficient matrix A, then you will calculate det A. If det A is not equal to 0, directly we write the system is consistent. If det A equal to 0, then you should go for adjoint A into B. If adjoint A into B is non-zero, then we say the system is inconsistent. If adjoint A into B is 0, then we say the system is consistent. I hope you are following this class, right? So this is the fourth question. This is 3 by 3 matrix related. For this question also, what they are asking from question number 1 to 6, they are asking where check the consistency of the given system of equations. See here, first I'll write coefficient matrix. And you need to observe, actually you need to observe these equations, especially you observe this third equation, ax plus ay plus 2az equal to 4. Here A is 100% not equal to 0. If A is 0, this will become 0, this will become 0, this will become 0. 0 plus 0 plus 0 is 0. But they given 4 here. It tells you that A is non-zero number. In the question they not specified related to A is non-zero number or not. By seeing these equations, you need to identify A is non-zero number. If A is 0, 0 into x is 0, plus 0 into y is 0, plus 0 into z is 0. 0 plus 0 plus 0 is 0. But here they are given 4. That's why we can conclude here, by seeing this third equation, we can conclude that A is non-zero number. Okay. They given 3 equations. They are asking to check consistency or inconsistency. What I'll do, first I'll write the coefficient matrix. What is the coefficient matrix? X coefficient 1, y coefficient 1, z coefficient 1, x coefficient 2, y coefficient 3, z coefficient 2, a, 2a. Unknown values I written in the form of ax equal to b. Now I need to calculate det A. You know how to calculate determinant of 3 by 3 matrix. I just calculated det A. 1 into, delete this row and this column, determinant of this part, minus 1 into, delete this row, this column, determinant of 2 to a to a, plus 1 into, determinant of, delete this row and this column, determinant of 2, 3, a. Now if you simplify this, you are getting further, you know how to do this. If you simplify this, you are getting A. As by seeing the equations, we identify that A is a non-zero number. A is not equal to 0. When det A is not 0, feel happy. Don't need to calculate further. Det A is non-zero. What we say? We say that the system is consistent. When det A is not equal to 0, the system is consistent. When det A equal to 0, directly you cannot write inconsistent. You should calculate adjoint A into B. After calculating adjoint A into B, only we can decide the system is inconsistent or consistent. We'll do one more problem to understand these things very clearly. See, this is the 5th question. In this question, what they are asking? They are asking to check the consistency or inconsistency for the given system of equations. First, what I'll do, I'll write these equations in matrix form. Here, coefficient matrices, x coefficient 3, y coefficient minus 1, z coefficient minus 2. You observe this second equation, they're not given anything related to x coefficient. They just given 2y minus z. That means x coefficient can be, this can be written as 0 into x plus 2y. 0 into x. So if nothing is given here, we'll just write 0. In place of x coefficient, we'll write 0. Y coefficient 2, z coefficient -1. Here you see z term is not given. That means z coefficient we'll write 0. 3, -5, 0. Unknown values x, y, z, and this matrix B, 2, -1, 3. First, I written given linear equations into matrix form Ax equal to B. Now I'll calculate det A. You know how to calculate determinant of 3 by 3 matrix. I calculate det A. See here, I'm calculating. You know how to calculate det A, so I'm not explaining this. You can go through this. After calculating det A, what I got? I got 0. Then the problem will arise. If det A is 0, what to do? You should calculate adjoint A into B. This is 3 by 3 matrix. For 2 by 2 matrix, adjoint A we can write very easily. This is 3 by 3 matrix, right? We learn all these things in earlier classes also. What is adjoint A? Transpose of cofactor matrix. So what to do? You need to calculate cofactors of all these elements. Cofactors of all these elements. All these elements. Capital A 1 1, capital A 1 2, capital A 1 3. I calculating cofactors, right? Now second row first column element cofactor, second row second column element cofactor, like that cofactors. As we discussed how to calculate cofactors in earlier classes, I am not explaining these things again. Please, if you do not know how to calculate the cofactors, you cannot do this exercise. Because coming problems also, every problem we are going to calculate cofactor. Last exercise is all about finding minor cofactor. Please be good in the last exercise, then only do these problems. I am not explaining here. I just written the solution. You just calculate cofactors of each elements. It is must. You must be good in how to calculate cofactor of each element. I calculated cofactors of all the given elements, and now I am transposing. What is the definition of adjoint A? Adjoint A is the transpose of cofactor matrix. I just transpose this matrix -5, -3, -6, 10, 6, 12, 5, 3, 6. Right? This is adjoint A. Okay. They are asking to check the consistency or inconsistency of the given equations. I taken a coefficient matrix. I calculated det A. I got 0. As I got det A is 0, I am calculating adjoint A into B. Adjoint A just now I got. You know what is B. This matrix is there now here. 2, -1, 3. This is the matrix B. Adjoint A into B. Okay, first I written this matrix adjoint A and I written the matrix B. You need to multiply these two matrices. See, in case if you do not know matrix multiplication, you can't do this problem. So, you must be good in matrices chapter and matrix multiplication. First row, first column. Multiply -10 plus of -10 plus 5 3s are 15. Okay. Second row, first column, -6 plus 6 into -1 is -6 plus 3 into 3 is 9. Third row, first column, -6 into 2, -12 plus 12 into -1, -12 plus 6 into 3, 18. You simplify this further. You got a matrix like this. When I calculate adjoint A into B, I'll get a matrix. Is this matrix is 0 matrix? If all elements of the matrix are 0, then we call it as a 0 matrix. This is not 0 matrix. This is non-zero matrix. When adjoint A into B is non-zero, as per the second case, we discussed a total 3 cases now. As per the second case, det A is 0, adjoint A into B is non-zero, then we say the system is inconsistent. I hope you got some clarity related to consistency and inconsistency. One more problem is there related to consistency and inconsistency. See, this is the question, 6th question. What they are asking, check the consistency and inconsistency of these equations. I want you to try this problem your own, whether the system of equations is consistent or inconsistent, right? Please try this problem. What to do? First write the matrix form Ax equal to B. Calculate det A. If det A is non-zero, feel happy, because directly we can write the system is consistent. In case det A is 0, you should go with adjoint A. You must calculate adjoint A. How to calculate adjoint A? That we learn in earlier classes, right? Calculate adjoint A. After that you multiply adjoint A and matrix B. If the answer is non-zero, we say inconsistent. If answer is 0, then we say it is consistent, right? So this is all about practice. I am saying again and again, just simply watching the videos, you may not be 100% perfection, you may not get. please take pen paper, start practicing these problems. When you practice these problems, then you will identify actual difficulty in this, and your doubts also will be cleared when you practice your own. Right? I hope you understand this class. Thanks for watching this video. Have a great day. Bye bye.